Hello everyone, I am Jyoti Patil and today I will be discussing addressing modes and instruction set in 8051. Addressing modes of 8051. So, what are addressing modes? The way in which data will be accessed by different instructions will be nothing but your addressing modes. So 8051 has 5 different types of addressing modes. That is your immediate addressing mode, direct addressing mode, register indirect addressing mode, and indexed addressing mode. So each of this we will be studying further. The first addressing mode is immediate addressing mode. In this mode, the data is made as a part of code. That is, whatever data you need to move in any of the register is directly given as a part of instruction. For example, move a comma hash 27. In this, 27 needs to be moved into accumulator. So here what we will be doing, in front of 27, we will write a hash sign to indicate that it is immediate addressing mode and whatever data is there, it needs to be moved directly into accumulator. Similarly, add R1 comma hash 45. So what it does, the content of R1 is being added with 45H. Move dptr comma hash 8245H. So dptr is 16-bit register and so 8245 16-bit data can be moved into data pointer. Move p1 comma hash 21H. Here port 1 is assigned with data 21H. Register addressing mode. The addressing mode involves the use of registers to hold the data to be manipulated. Both source and destination are registers and their sizes should match. For example, move a comma r0. So in this, a and r0 both are registers and the content stored at r0 will be moved into accumulator. Next, add a comma r6. The content of register r6 will be added with contents of accumulator. Next, move p1 comma r2. The contents of register r2 will be moved into p1. Move r5 comma r3. The content of register r3 will be moved into register r5. In register addressing mode, the registers from r0 to r7 can be used. The next addressing mode is direct addressing mode. In direct addressing mode, the data is in RAM location whose address is known and the address is specified as a part of instruction. Okay. So in direct addressing mode, what we will be doing, for that we will see an example. Move R1 comma 42H. So in direct addressing mode, what they do is they give the address of the memory location where data is stored. So from that memory location, we need to access the data. So like for example, move R1 comma 42H. Here the contents stored at memory location 42H will be moved into R1. Move 49H comma A. So whatever data is stored in accumulator A will be stored at memory location 49H. Add A comma 56H. Here the content stored at memory location 56H will be stored into accumulator A. The next addressing mode is register indirect addressing mode. In indirect addressing mode, it uses register to hold the address which contains the required data. In other words, the content of register is a pointer to the data address. So like what is pointer? A pointer is a variable which points to the address of another variable. So similarly, in register addressing mode, the content of register will be a pointer to the data address. So whenever we are using indirect addressing mode, the data will be inside the CPU, then only register R0 and R1 can be used. And when R0 and R1 are used as pointers, they must be prefixed with hash symbol. So first example, move a comma at the rate R0. So R0 will be equal to, say if R0 is equal to 40H, assume. So R0 is equal to 40H, and that 40H will be treated as memory location. So content stored at 40H memory location will be moved into accumulator, and so value of accumulator will be equal to 21H. Similarly, move A comma, move at the rate R1 comma B. Here B, whatever content of B register will be there, those will be moved to R1. Say like R1 is pointing to some memory location. So whatever content is present at that memory location, that there B's data will be stored. The next addressing mode is indexed addressing mode. This addressing mode is used to access the data of lookup table entries located in ROM space of 8051. Okay, so what are arrays? Arrays will store the elements one after the another. So say if you want to access some element of array, what you can do is the first element of that array, that's address can be stored in some register. So that will be the base address of that register. So depending on that, if you give some other element's address, directly you can access that element. So that kind of scene works in indexed addressing mode. So for example, move C A comma at the rate A plus DPTR. So if DPTR will store the base address of the array. So next A will have at what particular element by what values or what location you need to move ahead, that value has to be given in A. So A plus DPTR, that will form one particular address. So at that address's memory location, whatever data is stored, that data will be moved into accumulator. Next is instruction set in 8051. The instructions are grouped into 5 groups: arithmetic instructions, logical instructions, data transfer instructions, and branching instructions. Arithmetic instructions. So whatever basic arithmetic operations are being performed on the operands will be your arithmetic instructions. And that the first is add. Add ADD, it performs 8-bit addition between accumulator and the second operand. Whatever result we get after performing this instruction will be stored in accumulator. Because of this, only carry flag will be set or reset. If you get a carry, it will be set. If not, it will be reset. Next instruction is add C. That is nothing but add with carry. It is also 8-bit addition between accumulator and the previous carry generated. So if when arithmetic operation was being done, if that time any of the carry is being generated, if you want to add that carry, then add C instruction will be used. This is very much useful for 16-bit addition in 2 steps. Here also the carry flag will be affected. Next instructions are logical operations or like logical instructions. And that first one is ANL or ORL. This instruction is used to perform AND operation between accumulator and second operand, and similarly OR operation between accumulator and the second operand. It will work on byte-sized operands. Byte-sized in the sense it will perform 8-bit logical operation, logical and logical OR on the operands or the carry flag. Next is XORL. It performs XOR operation between your accumulator and any of the second operand, and the result is always stored in accumulator. Example, move A comma hash 32H. Move R4 comma hash 50H. So here you can see move A comma hash 32H. Since it is immediate addressing, accumulator will be assigned with the data 32H. Next, move R4 comma 50H. So here 50H content will be 50H data will move into R4 register. So A is 32H and R4 is 50H. So as in XORL operation, one register has to be always accumulator. So we will perform XOR between A and R4. So what data we will get is 62H after doing XOR operation. Here also, this also works only on bytes. That is, it performs 8-bit operation. Next is RLA, in the sense rotate left the accumulator. This instruction rotates the contents of accumulator towards the left. That is, MSB is moved to LSB after the rotation. For example, move A comma hash 69H. So what this instruction does, it moves 69H data into accumulator. So A will be 0 1 1 0 1 0 0 1. So next, rotate left A. So what it will do, you can see in A, 0 is MSB and 1 is LSB. So here the data is moved towards left. It is shifted towards left. So after shifting, 0 goes to LSB. So now after rotating, the data will be 1 1 0 1 0 0 1 0. Similarly, again, if you rotate the data left, again same. Again the MSB will move to LSB and the data moves to the left. Similarly, rotate left with carry. This instruction rotates the bits of the accumulator towards the left. The bits are rotated out of the register and one bit is copied into the carry bit, and that is rotated to the opposite of the accumulator. For example, first you will clear the carry flag, then you will move 99H into the accumulator. So RLCA, this what it will do, it will move the MSB into the carry flag. So that time carry flag becomes 1, and since carry was 0, it will be moved to the LSB side, and so on. Next, RRA, rotate right with the accumulator. This rotates the bits of accumulator to the right. Same as rotate left instruction. Similarly, rotate right instruction will be working. Move A comma has 69H. There it was moving towards the left. Here it will move towards the right. Here LSB will go to the MSB. Next, rotate right with carry. Rotate right with carry. This rotates the bit of the accumulator right. The bits are rotated out of the register and are rotated into CY. And CY bit is rotated into the opposite of the accumulator. Next instruction is swap A instruction. The swap instruction is used to exchange the lower and higher nibble with each other inside the accumulator. So if you need to exchange the nibbles, then that data you need to store it into the accumulator and then you can exchange the nibbles. For example, move A comma hash 59H. So if I want to make the answer as 95, I can use swap instruction wherein it will exchange the nibbles of the data. Next is CPL, clear A or CLI. This instruction will complement the accumulator or it will clear the accumulator. Complement in the sense it will give not operation, whereas clear will clear the accumulator. So whenever anything needs to be clear, it has to be stored in accumulator. Next instructions are data transfer instructions. And that first one is move. It is 8-bit data transfer for internal RAM and SFR. And that first one is move A comma RN. What move instruction does is, move instructions copies the contents of source register into destination register. And that the first is move A comma RN. So what this instruction does is, the RN register may be R0 to R7 any register. So content of that register is moved into or copied into accumulator. Similarly, move A comma direct. The direct addressing in the sense whatever direct address we will provide, the contents of that memory location will be moved into accumulator and so on. The next instruction is move C. Move code byte. What this instruction does is, it copies a byte of data from code memory and loads it into accumulator. It uses indexed addressing mode. Next, move X. This instruction copies the data from external memory to the accumulator or from the accumulator to the any of the external memories. Push or pop. Push and pop are used to write the data or read the data from the stack. How this instruction works is here push DPL. So what it does, push instruction copies the content of DPL onto some memory location and it increments the pointer by 1 or 2 values. If it is 8-bit data, the value is incremented by 1. If it is 16-bit data, the value is incremented by 2. And then pop instruction decrements the value by 1 if it is 8-bit data, and or if it is 16-bit data, the value of the pointer is decremented by 2 and whatever data is stored at that particular memory location is taken out. XCH, exchange accumulator and a byte variable. So what XCH instruction does, it exchanges the destination and source contains. The next instructions are branching instructions. Branching instructions are of two types, call instructions and jump instructions. So first we will be studying about call instructions. Call instruction is used to call the subroutine. Subroutines are the programs which perform specific tasks repeatedly. We can relate subroutines to recursion. Like as in recursion, we execute or call specific function again and again. In the same way, subroutines are the task which needs to be performed again and again. Because of this, we can make the program more structured and because of which even we can save the memory space. So 8051 has two types of call instructions, long call and absolute call. So what is long call? Long call is a 3-byte instruction in which the first byte is opcode and second and third bytes are used for address of the target subroutine. So that subroutine may be located anywhere in the 64 kilobyte address space. So what this thing does is whenever a subroutine is called, the control is transferred to that subroutine. So that time before subroutine, whatever address was there, that address is stored onto the stack and the control is transferred to the subroutine. So once when subroutine is executed, at the last of subroutine there will be an instruction called as return. So that return instruction puts the address of the main program back, because of which the execution goes out of subroutine and the main program starts executing then onwards. The next instructions are unconditional jump instruction. In that the first is long jump. Long jump instruction is a 3-byte instruction in which the first byte is the opcode and second and third byte represent 16-bit target address. Okay, so whenever you need to access any memory location within 64 kilobyte of program memory, we will use long jump instruction. So what this jump instruction does is it jumps to particular memory location without any condition. Similarly, short jump. It is a 2-byte instruction and it is capable of accessing the memory within 2 kilobytes of memory.